Welcome to The Switch. I'm Elena Casas. Factories that produce fertiliser separate hydrogen from natural gas and combine it with nitrogen taken from the air to make ammonia, which farmers then spray on the soil to maximise crop growth. That requires fossil fuels, but increasingly companies are turning to using hydrogen from water instead to create so-called green ammonia. Well, I'm joined now by Olivier Mussat, CEO of green fertiliser producer Atome. Olivier, hi. So the traditional production of fertiliser needs natural gas, both as a feedstock, as an ingredient, and as an energy source. So how are you replacing it?
So there is no real secret sauce. You take water, H2O, and with electricity, green electricity, you separate the H and the O. The oxygen is released in the air. The hydrogen, which is zero carbon hydrogen, then goes into a regular fertilizer plant. And on the other side, you end up with a fertilizer which has more than 90% lower carbon footprint than half of the world's fertilizer based from hydrocarbon.
You said there that it reduces the carbon emissions of fertiliser by 90%. Is that from using renewable energy in the production or also from the emissions of the fertiliser once it's been spread on fields?
Both. Right. The first part is indeed, the source of energy. The source of that hydrogen is zero carbon. But then on the use side, we will be producing calcium ammonium nitrate. When you actually put it on the ground, if you compared it to urea, for example, it also has a low to nil carbon footprint. So it's a winner from the producing side. It's also a winner from the utilization side.
How close are you to going into industrial scale production?
So we have now finished front-end engineering and design from the first plant. We have secured power purchase agreement in Paraguay. So we are in Latin America because this is where you have the most competitive sources of power, baseload hydroelectric power. Also where you have the biggest fertilizer market in the world because most of the world is now fed by Latin America. And this will be the largest industrial scale fertilizer plant in the world in operation by the end of 2027.
Why is your first plant in Paraguay?
So the important thing when you look at developing green fertilizer projects is obviously the supply of green power, number one. Number two, the demand side. So as we mentioned, we are producing fertilizer, which is a regular fertilizer. It just happens to be zero carbon. So you want to produce something close to your market where you can really shorten that chain, that supply chain, and you are therefore much more competitive and you can compete head-on with hydrocarbon fertilizers without any need for subsidies because you don't have to transport it, you are very close to your markets, you know that you have a market a lot bigger than what you will ever need. So it puts you into a great competitive position. So that's really supply close to demand at the right price for the right market.
Paraguay is a fairly underdeveloped country. Does it have an abundance of green electricity?
So Paraguay has a number of things going for it. It's the world's largest exporter of organic sugar. It's the world's second largest exporter of stevia, fourth largest exporter of soybean. And yet, yes, not too many people have heard about Paraguay. But its largest export, by a long shot, is actually renewable power from the Itaipu Dam. It's a 14 gigawatt dam, hydroelectric dam, which is the second largest in the world.
What's the difference in cost between your process and making fertiliser traditionally?
It all comes down to the price of power and the quality of power. So thanks to the partnership that we have in Paraguay with Ende, which is the power supplier, we are pretty much on parity. And that's pretty unique. Again, that's part of the uniqueness that in a region which imports 95% of its fertilizer are inherently expensive. And because we have some of the most competitive cost and type of power in the world, we are able to produce it much cheaper than anywhere else in the world with zero technology risk. So it all balances out. Clearly, if we were producing it elsewhere in a country where the price of power will be extremely high, where the logistical cost will be also much higher, it will be much more difficult to be competitive with hydrocarbons.
The production of ammonia, though, does require some emissions of nitrogen oxide and of particulates from the process. What about the impact of the pollution from this plant on the local community?
So that's an excellent point, right? And a regular plant, an old style of plants, used to generate a lot of nitrous oxide, NOx, and emissions. And what we are doing, even though we are in Latin America, is we are using the latest and highest European standards. Casale, who's our engineering firm who is building this plant, has obviously all of the kit to make sure that we are lower than all of the international emission standards. We overlay on it the fact that some of us come from the World Bank, so we are using the IFC performance standards, which are the most stringent environmental and societal standards around, to make sure that we operate a no-harm plant and that we get the communities completely aligned with what we are trying to do, obviously for the farming sector, for agriculture, and also for our local communities and enabling job creation.
How much of the emissions from agriculture do you imagine that green fertiliser could eventually displace?
So let's take a step back. Right? The fertiliser sector by itself represents more emissions than shipping and aviation combined. So as a very basic example, you and I can decide to fly to Ibiza for the weekend and pay a premium for the carbon emission reduction. However, when it comes to food, we don't have a choice. We need to eat. And that's about 5% of global emission related just to fertilizer. So the impact that you can have is obviously huge because it's going to be a growing problem.
Olivier Massat, CEO of Atome, thank you so much for joining us.
Thank you so much, Elaine.